Hi everyone, so we're going to have a recap of topic 5 on energetics. Let's start with the key terms, endothermic and exothermic. So exothermic reactions are reactions that transfer transferred heat or thermal energy to the surroundings. And when thermal energy is transferred from the system to the surroundings, temperature of the surrounding goes up and energy of the system goes down. So if we look at the reaction pathway diagram for an exothermic reaction, if this is reactants, you're going to have the products which is going to be down because the system has lost energy as mentioned here. So energy transferred from the system to the surroundings. So the system has lost energy. So delta H is going to be negative. And as you're drawing the reaction pathway diagram, you need to have reaction progress here and energy on the y-axis. Right, so this is for exothermic reaction. The second reaction is endothermic reaction. Now for endothermic reaction, you have energy which is absorbed, energy taken in, for example, photosynthesis. So an endothermic reaction takes in thermal energy from the surroundings. So because it's taking energy from the surrounding, temperature of the surrounding will decrease, and because the system takes in energy, the energy of the system is going to increase. So when you draw the energy profile diagram for an endothermic reaction, energy of the system is going to go up. So if this is reactants, this is going to be products. And delta H is going to be positive. So for the core section, this is the only part that you have. Whatever I'm going to write now is going to be for the extended part. Now we're going to see the activation energy, EA. So activation energy is the minimum energy that the particles which are colliding must have for a reaction to take place. This is the definition. If we draw a reaction pathway for, this is an exothermic reaction. So here, this is going to be delta H. From reactant to product, delta H is negative. But from reactant to the highest point of the graph, this is activation energy. So this you have to be able to label in a reaction pathway. Now for an endothermic reaction, you have the same thing. Delta H is positive now. And from reactant to the highest point of the graph, here, this is going to be the activation energy. So you should be able to draw and label the reaction pathway diagrams for both endothermic and exothermic reaction. Now let's look at bond breaking and bond formation. Any bond breaking reaction is endothermic, and any bond formation reaction is exothermic. And in order to find delta H of a reaction, delta H of a reaction is energy absorbed during bond breaking minus energy released during bond formation. As simple as this. Now, when you have a reaction where the overall delta H is negative, if overall delta H is negative, so overall the reaction is exothermic, it means that the value of bond formation is greater than the value of bond breaking. When this value is higher, then delta H becomes negative. So then the energy released during bond formation is greater than the energy absorbed during bond breaking. That's why delta H becomes negative. And the same is true the other way around. So when energy absorbed during bond breaking is greater than energy released during bond formation, when this value is greater than this value, then delta H becomes positive. So big value minus small value, this becomes positive. So this is all the theoretical part of the chapter, and then you should also be able to apply this formula in calculation. So for this you will need to practice questions. So this is a summary of topic 5 on energetics.